All right, let's take a look at determine the key points of a parabola in graphing form. Step one right here is determine the vertex. So the vertex is coming from the numbers that are in your equation, and they are the h and k values in your equation. So the coordinates of the vertex are located at h comma k. One of the things I've told students before is think about h and think about k and make them into a word. So this one I'm going to make into the word keep. This word I'm going to make into the word change. So it's a change keep situation. So the h and the k are referenced from the h and k values that are in your equation. So this is the one that you change. So you would be thinking that it's -5 when it's actually just plain old 5. This one we're going to keep as in -4. So that tells me that as I go to write this vertex, it would be located at +5 and -4. Okay, so that's how you do that. And you remember it by change keep with the h and k that are in there, so that should help. The next step is for you to go to graph the parabola. If I want to graph the parabola, then I'm going to need some coordinate points to do that. If I've already figured out my vertex being at 5, -4, and if I go over here and I plot that point, that's at 5, -4, I really don't have the shape of a parabola just because I know one point. That's a really important one, so I do like the fact that that is at 5, -4, and that's great, but that doesn't help me finish it up. So in actuality, what I'm going to need to be able to do here is be able to make a table of values so I can kind of see what this thing is going to look like. So if I have my x and y coordinate table, I know that 5, -4 is kind of the middle of my table, so to speak. So I'm going to put 5, -4 kind of in the middle so I can try to figure out the rest of the points. So then I'm going to have a 4, 3, 2, 1, 0 potentially, maybe a 6, 7, 8, 9 going this way. And then what I have to do is I have to plug those into the equation to figure out what they are. So literally I'm taking 6, and 6 would be my next point. So I'm going to take this 6 right here, and I'm going to plug it into my equation. That's right here. So 6 take away 5 makes 1. 1 squared is 1. Take away 4 would make -3. Again, that can be a calculator typing activity. As long as you type it exactly that way, your calculator would then give you the proper coordinate of that one being -1. The same thing's going to happen on the other side of the vertex. I'm sorry, -3. The same thing's going to happen on the other side of the vertex when I go 1 point away, because I'm also going to get a 1 squared situation. That one's also going to be -3. After doing a few parabola situations, you start to learn that you have the patterns here. When I do the 7, I'm going to get a 0 and a 0 here. And when I do the 8, I'm going to get a 5 and a 5 here with the 2. And then when I do the 9, I get a 12. And so then when I do the 1, I'm also going to get a 12. To show you that, if I put 1 into the equation, so if I put 1 right here, 1 take away 5 squared, that would be -4 squared, would be 16. 16 take away 4 is 12. That's why the 1 ends up being a 12. So I did a little bit of that work ahead of time so that I know those were the answers. Then I'm going back over here to the graph, and I'm plotting those points. So there's the next points, and then the next ones were at 7, 0, so 7, 0 is here. And the other one was 3, 0, so 3, 0 is here. Now I technically have enough to graph it. If you want to go one more, you could go one more. So then I'm going to go, the next one was at +5, so that would be here, I believe. And so then if I'm at, let's see, 5, 6, 7, 8, 5 would be here. And then this one would be here. So now I've got my graph set up, and I can make my parabola go something like this. And what I like about this particular drawing that I just made is that I do actually have the intercepts. So now I can clearly see I've got the intercepts there and there because they're hitting the x-axis right there at those 2 points. So now I can see the vertex, which is down here, and I've got the intercepts right there. So things are going well for me. Now the only thing I didn't really figure out yet is this guy right here, which is going to be the y-intercept. What happens when I plug in 0 for x? So when I plug in 0 for x, if I go back over here and do that, and if I put the 0 in there, then I would have 0 take away 5 quantity squared minus 4. So that's -5 quantity squared, which makes 25. And then -4, that's where the +21 comes from. I can't even see that on my graph. It's way up here somewhere, this thing would go up and hit at positive 21. That's why it's basically off the screen. So determining the x-intercepts is pretty easy. I can also see those in my table at 3, 0, and 7, 0, or I can just simply look at them over here on the graph. That is at 3, 0, that's at 7, 0. It matches my table, so then I'm able to put those numbers back over here. So 3, 0, and 7, 0, typically listing them from least to greatest. And then my y-intercept would be 0, 21, way up the sheet or the graph. And then it says determine the line of symmetry x equals. Well, we know we've been stealing the x coordinate of the vertex every time to do that. So this guy right here, this 5, is going to be my line of symmetry, so x equals 5. And if I just draw that line in, that would be the vertical line right here, this green line on my graph, that would cut the parabola in half, and that would be its line of symmetry. But that's basically just stolen from the x-coordinate. So to find the vertex, you need the h and k value. To graph it, you should be building a table, and you should know you have some mirror image numbers that keep showing up, like repeats that are apart from each other. And then we've got the intercepts at 3, 0, 7, 0, which are these points down here, 3, 0, 7, 0, also shown in the graph. And then the y-intercept is when 0 equals x, so that's when I put the 0 in and into the equation. And then the line of symmetry is at 5. That's where the x-coordinate of the vertex is.